Hi everyone, in this video we'll look at another example involving transformations of functions. Here we're told that for the given graph we want to identify the base function, we want to state the transformations applied to the base function, and lastly write an equation for the base function. Sometimes you'll hear me say that parent function instead of base function. They mean exactly the same thing. So parent function is base function. They're the same thing. So first off, let's identify the base function. And we can identify what the base function is by just thinking of what function I can transform to get this graph. And if you think about it, the base function is equal to y is equal to the absolute value of x. If I think about what the absolute value of x looks like, it looks like this. So this is my parent function. It's symmetrical about the axis. X is equal to 0. It has a vertex at 0, 0. And for any values greater for x greater than 0, it is the line y is equal to x. For values that are less than 0, it follows the line y is equal to negative x. So I can transform this function, y is equal to the absolute value of x, in order to get this function. So that's what I have to do in the next part, is I have to state the transformations applied to the base function. So the first thing that I normally do is I normally try to figure out what the translations are. So here, to figure out what the translations are, I always look at a point on the origin of my initial graph. I say, where did the origin get translated to on my transformed function? The reason that I do that is because the origin 0, 0 is invariant under stretches, reflections, and compressions. That's because when you stretch, reflect, and compress this point, it stays in the same spot. So that's what invariant means. So let's go ahead and figure out what the translations were. Well, I moved this this coordinate to the right 2 units and up 3 units. So there is a horizontal shift, horizontal shift 2 units right, and a vertical shift, or vertical translation, 3 units upward. So what that tells us is that our value for D is going to be equal to 2, and our value for C is going to be equal to 3. Next, let's figure out what our other values are. So I have you might have already noticed this, but I definitely have a reflection about the x-axis. So there's a reflection about the x-axis. That means that my value for A is negative. So there's a reflection about the x-axis. And now we need to figure out if there's been any stretches or compressions. So let's look at the regular step pattern or the regular slope of this graph. Normally I go over 1, up 1, over 1, up 1, over 1, up 1. And after I've reflected this, I'm going over 1, down 2, over 1, down 2. So there is a vertical stretch by a factor of 2, because if I were to just translate and then reflect without stretching, the graph would have looked like this. I would have had a point here, and then my next point would have been here. My next point would have been here. I would have had a point here, a point here, and a point here. So you can see that if I take all of these points, or if I look at each of these points, this point that's on this graph is a vertical stretch by a factor of 2 of the point that I've plotted from this from this line here. So there's a vertical stretch by a factor of 2. And I'll just get rid of all those points there. So there's a vertical stretch by a factor of 2. We can also think about this as a horizontal dilation by a factor of 1/2. So I can think about this as a horizontal compression as well. But if I think about it as a horizontal compression, then there's no vertical stretch. So it's kind of tricky here because this can be thought of as either a vertical stretch or a horizontal compression. Lastly, let's go ahead and write an equation for this for the base function. So I have that since I have a vertical stretch by a factor of 2 and a reflection about the x-axis, I know that a is equal to -2. I've already discovered that d is equal to 2 and c is equal to 3. So the equation for my base function, this shouldn't say an equation for the base function. It should say an equation for the transformed function. I already have an equation for my base function. So this should be an equation for the transformed function. Okay, so I've got y is equal to -2 times the absolute value of x minus 2 plus 3. And I write it like this because remember that your transform function, if you have the function f of x, then the transformed function looks like this. It looks like a times f of bracket k times x minus d close square bracket plus c. And here we do have that k is equal to 1 because if we think about there being a vertical stretch by a factor of 2, then there's no horizontal dilations. So k would be equal to 1 in this case. So I just basically went ahead and I filled in this formula here with the values of a, d, and c. And I included k in there as well. It's just that k is equal to 1. So hope you enjoyed that lesson, and we'll see you in the next video.